Welcome back to Elements of Chemistry. So far, we've covered the metric system, and in metric conversions, we started using what we call the ratio method. That's called dimensional analysis. You'll also see it called the factor label method. It's the art of using units to solve a problem. In chemistry and physics, an analysis of the unit of measure and unity ratios or conversion factors help us solve a problem. A conversion factor is a ratio from the equality between two units, like 60 seconds equals 1 minute. 16 ounces equals 1 pound. 1,000 millimeters equals 1 meter. The key to getting your units is to cross cancel each other out. So you always start by taking your given and multiplying it by some conversion factor or unity factor. And you work in ratios. So in this example, we picked a real simple one to start with. We have 120 seconds. That equals 2 minutes. Well, we know that one pretty easily because we know that for every 1 minute, there's 60 seconds. But if we look at it in math-wise, what's happening here? We're taking 120 seconds, our given, we're taking the unit of the given seconds and putting it in the denominator of our conversion factor. Because a conversion factor can be written either way. You can write 1 minute over 60 seconds, or 60 seconds over 1 minute. And the key here is you want the unit that you want to get rid of on the bottom so that it cross cancels out. So let's try some together. Here we want to convert 1.35 years into days. Okay, well, what do we know? Well, we know the unity value. For every 1 year, there's 365 days. We're going to ignore leap year to make this a little simpler. So we start with our given 1.35 years. We know in our ratio or our conversion factor, we're going to need years on the bottom so that it will cross cancel. So we put the 1 year on the bottom, the 365 days on top. We're then going to cross cancel our units. And mathematically, we're going to take 1.35 times 365, and that's going to give us 1,825 days. Now, we haven't talked about significant figures yet. That's a couple of videos down the road. We would then have to go and round our answer to the correct number of sig figs. But right now, we're going to leave it just as the whole number so you can see it. So see how the key, a numerator, has to cancel out a denominator. Let's try another one together. We're going to take 1.2 times 10 to the 16th. So now we're in scientific notation. Seconds, and we want to take it into a year. Well, we don't know that conversion straight off the bat. What do we know about seconds? Well, we know that for every 60 seconds, I'm going to want seconds on the bottom. We have 1 minute. That's a value that equals 1. Okay, so that allows us to cancel out our seconds, but that still doesn't take us to years. So then we're going to need to get rid of minute. So we're going to want to put minute on the bottom. Well, what do we know about a minute? Well, we know that there's 60 minutes in 1 hour. Okay, we're getting bigger. The minutes are going to cross cancel. Where does that take us? Well, we've got hours. Hours still doesn't take us to years, but we can get a little closer. We know that there's 24 hours in 1 day. Now you're starting to see it. The hours are going to cross cancel. We're going to now get rid of days, and we know that there's 365 days to 1 year. Okay, this is a lot of math. So I suggest you take it one step at a time. Some people will tell you you're going to multiply all your numerators together, and then you're going to multiply all your denominators together. Take your numerator, divide by the denominator. I think that's too much writing. The easy way to approach this is with your best friend, your calculator. So we're going to put in that 1.2 using our exponents to the 16th power. And this says we're going to multiply by 1 and then divide by 60. Well, multiplying by 1 is the same thing, so we're just going to divide by 60 and press enter. And now we're to this point of our problem. Now we're going to multiply by 1 again and divide by 60 again. Divide by 60. Now we're to here. We're going to multiply by 1 and divide by 24. And each time you do one of these steps, go ahead and press enter. Your calculator is going to keep a running total for you. And then finally divide by 365. And that is going to give us 380,517,503.8 years. Wow, that's a really long time. Let's put some commas in so we can get a size of that number. Now, once again, when do we know to stop writing all of these digits? Significant figures is going to be the key. Later on, you're never going to ask where to round. In this case, I would have rounded it to 380 million years. Wow, that's a long time ago. It didn't look that big when we were thinking about it in seconds. So now it's your turn. Let's take one and let's convert dollars into quarters. Remember, there are 4 quarters in a US dollar. So we'll give you a minute to do that one. Then you're going to convert 4.5 ounces, pounds, excuse me, 4.5 pounds into ounces. And I gave you a hint here for your conversion factor. So let's take a minute, try those. You can pause the video while you do that, or then come back and we'll do the problem together. Okay, you should have had some time to do those too. Let's check and see how you did. My little Oliver is whining here, sorry, in the background. We're going to take $147. What do I know about dollars? Well, there are 4 quarters to every $1. The dollars we're going to cross cancel out. We're going to take our calculator and go 147 times 4, divide by 1. And that's going to give me 588 quarters. If we look at this next one, we have 4.5 pounds. The abbreviation for pounds is LBS. And we're going to know that there's 16 ounces to every 1 pound. So once again, we're multiplying 4.5 times 16, divide by 1. It's going to give me 72 ounces. Remember, the key is to always make sure that you cross-cancel units. If you hadn't cross-canceled units, we're going to show you a mistake here. So we're going to do that in a different color. If we had done 4.5 pounds, and we said for every 1 pound, there was 16 ounces, well, that would have given us no, I made a mistake. 4.5 pounds squared per ounce. Do you see how the units didn't cancel each other out? So don't do that. Always make sure that your units will cross cancel. Sometimes you'll see ratios combined in what we call a track. It's called the train track method. It's really more of a monorail than a railroad, but it is faster to work it out. So let me show you how that would work on the track method. If we had 15 years, that's our given. This is going to be a conversion. This down bar separates each of your steps. We know we want years on the bottom, days on top, 365 days to every 1 year. The years will cross cancel. 15 times 365 is going to give me 5,000. What's the pencil? 5,475 days. That just replaced the 15 years times 365 days over 1 year. So you can see that this down bar acts as a multiplication sign, and the long crossbar is your dividing. So let's try some and test yourself. Once again, pause the video and then come back and see how you did on these problems. Okay, hopefully you tried these on your own. Let's go ahead and figure it out. And sometimes you can take alternate routes to a problem, but let's work through it. I'm going to use the monorail method, 165 nickels, and I want to go to quarters. Well, I know there's 5 nickels. Notice I almost wrote it upside wrong way. For every 1 quarter. I'm going to cancel that out. This one tells me I'm going to divide by that 5, and that's going to give me 33 quarters. Here we're going to take 756 days and use the monorail method. There's 365 days to 1 year. 756 divided by 365. That's going to give me 2.071232877 years. Okay, once again, this number is a bit absurd. Yes, it is mathematically correct, but it's not really significant. And one of the keys to thinking about significant figures, which we will get into in detail later, is always look at your given. This has 3 digits, so for good practice, we're probably going to need 3 digits in our answer, and my students would have written this as 2.07 years. And then I always make my students box it so we can see what their final answer is. So you'll see me do that quite often. Okay, here we're going to do a metric conversion. The nice thing about metric conversions is they always work for significant figures. So we have 175 milliliters. We want to get rid of milliliters, so milliliters goes on the bottom. We want to find liters, liters goes on top. We know there's 1,000 milliunits in a base unit. And there we go. I hope you got these right. In our next video, we're going to start tackling some more long, complex problems, more like the one that we did with this one up here, where we have lots of conversions. And we're going to start talking eventually about fractional units like miles per hour, meters per second, and then dealing with squared and cube units. So I hope you keep coming back and getting a little better at your dimensional analysis and converting between units. As always, stay curious, be kind, and stay safe out there. Have a lovely day.